అది కాదు సార్ మనకి 200 ఉంటుంది కదా చేంజ్ 49 అయింది సార్ అది.
अस्सलाम वालेकुम सर।
सलाम। वालेकुम सलाम। We were discussing about problems based upon thermochemistry. Let us take next problem. The next problem is something like this. I'm not solving this problem. What is that number? Tell me, is it 9 or 10? Question number. Yesterday, till which question we have discussed? 10. So let us start from 11. Should I start from 11? Yes. Okay, fine. Thank you. Question number 10. From the following data, calculate the enthalpy change of combustion of cyclopropane. Enthalpy of combustion of cyclopropane. This is cyclopropane, but we don't write like this. We write, because you people are strong in organic chemistry, they will write like this: cyclopropane at 298 kelvins. No problem. At 298 kelvins, he is talking about standard enthalpy of combustion. Data: enthalpy of formation of carbon dioxide. Write down the data like this: enthalpy of formation of carbon dioxide, comma, water, and propene. Enthalpy of formation of propene. Propene are minus 393.5, minus 393.5, minus 285.8, minus 285.8 and minus, sorry, and plus 20.42 kilojoules per mole. Okay, no problem. The enthalpy of isomerization, enthalpy of isomerization of cyclopropane to propene, something like this, is minus 33 kilojoules per mole. A small twisting has been created in the question. No problem. The people are genius, you can enjoy that. Come on, how to proceed? I don't take tension because of the word isomerization. First, I'll take care of the word enthalpy of combustion of cyclopropane. This is the compound. What is the formula? C3H6. And what is the formula here? C3H6, right? Alkenes and cycloalkanes are having same homologous series type of formula, right? Come on. First of all, he's asking, find the enthalpy of combustion. No problem. What I do, enthalpy of combustion of cyclopropane. No, it is not better to write like this because you may get confused. We have to write like this. You remember this one. It is as good as C3H6. Okay. Now, if I'm having combustion, it is undergoing oxidation so as to form carbon dioxide and water. 3 carbons available, 6 hydrogens available, 3 to the 6 plus 3, 9 oxygens also available. This is our demanded equation. Very simple, sir. Enthalpy of combustion of cyclopropane. No. It is called enthalpy of reaction. What I should say? Enthalpy of reaction. And when I say the word enthalpy of reaction, you will be ignited to say, okay, enthalpy of formation of products minus enthalpy of formation of cyclopropane. This is to be careful. And plus 9/2 enthalpy of formation of oxygen. And you know very well that enthalpy of formation of oxygen is 0. Standard enthalpy of formation. Come on. Now the question is, do you have this? Yes, sir. Do you have this? Yes, sir. Do you have enthalpy of formation of cyclopropane? No, sir. Enthalpy of formation of propene is given to you. Propene is given to you, right? Okay. That means now I have to proceed like this. Enthalpy of formation of cyclopropene, I'll write in this manner. Okay. Propene. Enthalpy of formation of propene. What is the meaning of formation of propene? Formation of propene means I have to go by this equation, propene, okay. But I want cyclopropane. For that purpose, simply what I do, I'll play a game. This is called conversion of cyclopropane to propene. Suppose, for example, if you reverse the equation, then what happens? It becomes propene to cyclopropane. And what do you want? Enthalpy of formation of cyclopropane only. Therefore, this should be written. No need of explaining in this manner. Simply you can go like this. This can be written like this. What? Sir, I am having propane, cyclopropane to propene, minus 33. No. I want conversion of this compound. We are talking about enthalpy of formation of cyclopropane. This compound is required. Reverse the arrow. Once you reverse the arrow, what happens? Are you able to understand that point? Yes. If it is so, then everything is over. Find out the enthalpy of combustion of what? Cyclohexane. Go ahead. Is the concept clear? Enthalpy of formation of cyclopropane not given to us, no problem. But he is saying how to come from propene to cyclopropane. Yes, he has given cyclopropane to propene. Reverse the equation. It becomes plus. Anybody got answer? 20971. Zahir, थोड़ा सा calculation check करो. -2071. Just calculation check करो. Thank you. 2068. This fellow is saying 2091. Difference 20 का कहाँ पे आ रहा है? -2091.32 kilojoules is saying 91. थोड़ा सा, did I made a mistake? 393.5, 285.8, 220.42, correct? -33. 2004 is wrong answer. 20, write down, no problem. In the brackets, all of you write down 2091 -2091 kilojoules. Right? बाद में check कर लीजिए. Concept समझ में आ गया. Don't waste time. Come on. Next question. Now, there is one more way of enjoying the questions here in this case. Just shall I remove? Is it over? Write correct answer, try later on. Come on. No. Enthalpy of combustion of ethane. make a star on this question. Enthalpy of combustion of ethane and ethine are minus 341.1 and minus 310 kilocalories respectively. Nice. Which is better gas for welding? Which is better gas for welding? This is the question. Now here we try to understand and enjoy one concept. What is the concept? Remember that gas for welding means he is talking about fuel. For example, petrol, diesel, kerosene, LPG. All these are fuels. There are so many types of fuels used here. Whenever we are talking about a fuel, what is a fuel? A substance which upon burning in presence of oxygen gives you heat energy, right? If it is so, right, we can convert that energy into electric energy, we can convert that energy into mechanical energy. There are different processes. Once you become IITian, you will enjoy all those things. So that should give you heat energy. That heat energy is called as calorific value. Sorry, it is measured as calorific value. What is the meaning of calorific value of a fuel? This you have to write down in the notes today. Calorific value of fuel is defined as the amount of heat energy released when unit mass of a fuel is burnt. Unit mass, CGS system, a gram is burnt. A gram of ethane, a gram of acetylene. MKs, SI units, 1 kilogram of ethane, 1 kilogram of acetylene. So the amount of heat energy released, write down the statement, calorific value, make subheading, calorific value. It is the amount of heat energy released when unit mass of a fuel is burnt. Fine. Now, second point. What is second point? Okay, sir, which one is efficient fuel? Which one is efficient? There are so many characteristic properties to say that the fuel is efficient. No one is going to ask us that one, all those things. However, if you are interested, see NCRT. But what is required for us is that fuel is said to be efficient, which gives you more energy. First statement, more energy. Sir, it should be portable, it should have less amount of byproducts, it should not have dangerous byproducts. That is all secondary stage, that is not required for me. What is required for me as a physical chemistry person? If energy released per unit mass is more, calorific value is said to be more. Higher the calorific value, more is the efficiency of the fuel. Okay, now it means to say 341 is more, 310 is less. Therefore, ethane is efficient than acetylene. Wrong. We should not say while seeing this one, because this is the amount of energy per mole. And whenever we are talking about per mole, that is not criteria. Criteria is 1 gram. Therefore, what we do, we simply go like this. For example, calorific value of, come on, ethane is equal to, we talk about magnitude only, 341.1 divided by molecular mass, 24 plus 6, 30, calculated, you get some number, alpha. No, sir, let us take about the second fellow, ethyne, acetylene, right? 310 by C2 H2, 24 plus 2, 26. Calculate this value, right? If alpha is more, ethane is efficient fuel. If beta is more, acetylene is efficient fuel. Therefore, efficiency of fuel should not be discussed with respect to amount of energy released per mole. No, that means enthalpy of combustion, doctors, enthalpy of combustion of a fuel is not a criteria for declaring it to be a better fuel. What is that? We have to find out the amount of energy released per unit mass of the fuel. Higher the value per unit mass, more is the efficiency. Go ahead. Saidur Rahman is saying that acetylene is more efficient. Anybody want to support this boy? Anybody want to oppose this boy? Yes, right. Even though, see that value 310, but it is getting more efficiency. Therefore, efficiency of fuel is independent of its enthalpy of combustion. It is decided by the final value obtained for a gram of the substance. Next. Very good. Question number 12. Similar discussion. An intimate mixture of ferric oxide, and aluminium is used as a solid fuel in rocket. This is not our interest here. No one is going to ask that. No problem. He's saying some story. Find the fuel value. Calorific value is also called fuel value. Find fuel value per gram and per ml. Therefore, he has not used the word calorific value, because if calorific value is there, it should be only per gram. He wants to say some other style. Therefore, he changed the language to fuel value. Right? What is data given to you? Enthalpy of delta H only given. Al2O3 is equal to 399 kilocalories. And enthalpy of, what is that? Fe2O3 is equal to 199, very good, kilocalories. And one more thing is given, density of Fe2O3, is 5.2 grams per ml, and density of aluminium is given, not alumina, aluminium is equal to, what is that? 2.7 grams per ml. Come on, now how to proceed? Very simple, sir. Whenever we are having this type of discussion, normally what we do, we'll use this fellow as a fuel. And what is the job of fuel? He has to burn in presence of oxygen to supply energy. Therefore, we have to go for oxidation process, right? Of what we are having aluminium and all that. Instead of doing that stepwise manner like IP student, what I do, I'll proceed like this. What happens? Aluminium will react with Fe2O3 so as to give you Al2O3. Go back to your third group in inorganic chemistry, Goldschmidt's aluminothermite process. This is the reaction there. And Krishna Mohan sir might have said you this is supposed to be a very highly exothermic reaction, and the energy release is abnormally high, and that energy is used for welding and cutting purpose of huge metallic structures. Now, if you want to balance the equation, it will be something like this, right? This is enthalpy of reaction between these two fellows. Now, I want to say enthalpy of reaction going on in case of a rocket fuel container is equal to what I should say. It is supposed to be enthalpy of formation of alumina. Enthalpy of formation of alumina Al2O3 plus 2 times enthalpy of formation of iron. You know it because if people are genius, so it is 0 minus enthalpy of formation of Fe2O3, right? Plus 0. Now, go back to the question. Sir, enthalpy of alumina is given, not formation, not formation. He has not given formation. What he has given, naturally, he has to give combustion reaction, and this must be combustion of aluminium, therefore formation of Al2O3. Are you able to understand my point? This is combustion of aluminium because he's using this word aluminium, combustion of aluminium, therefore we are having this fellow. Therefore, both of these are formation of Al2O3, formation of Fe2O3. But how to read it? Combustion of aluminium. What is the advantage of that? Minus 399. Are you able to understand? He has given positive value, right? But here in this case, instead of saying the word enthalpy of formation, is of course enthalpy of formation, but I'll read it as I said in the previous class, enthalpy of formation of carbon dioxide is equal to enthalpy of combustion of carbon. Similarly, enthalpy of formation of water is equal to enthalpy of combustion of hydrogen. Come on, cheating. Enthalpy of formation of alumina is equal to enthalpy of combustion of aluminium. Enthalpy of formation of Fe2O3, enthalpy of combustion of iron. But when you say the word combustion, you have to make it as negative from your side, minus 199. This accounts to how much? 200. Which 200? Minus or plus? Minus 200. What is the units? Kilo, where is the calories? Fine. Now the question is, this is the amount of energy released when this reaction takes place. No, sir, I want the value for 1 gram of the fuel. Who is that fuel? This is fuel. This is fuel. If it is fuel, then what I should say? 2 into 27 grams. Are you able to enjoy the point? Yes, total mass of aluminium plus iron 56 into 2. 112. Oxygen 16 into 3, 48. 112 plus 48. How much? 160. For this many grams of fuel, I am getting energy 200. No. I don't require this one. I require for dash 1 gram. Therefore, the fuel value per gram is equal to 200 by this number, right? Kilo calories, what are units per gram. Now, some of you may got idea to do some next problem. Very simple, sir. Let us go for volume. How to go for volume? Density is equal to mass by volume. Therefore, volume of aluminium plus volume of Fe2O3. Mass, you know it. Density given to you. See, the density of aluminium is given, density of alumina, Fe2O3 is given. This is total volume. How many ml? Alpha ml. Okay, alpha ml is equal to 200. How many ml you require? 1 ml. How much? Fuel value per ml is equal to, and what is that? That is beta kilocalories per ml. Go ahead. बेटा अब्रार एज यूजुअल आप समझने की कोशिश नहीं करते, पर लिख देते पहले। थोड़ा सा रुकिए, उसके बाद आपको फील होगा कि अरे गलती हो गई सर। आपके 2 कान को तो 4 कान बनाइए, सबके लिए बोल रहा हूँ मैं। आर्य सर की क्लास में 2 कान से काम नहीं चलता, 4 कान होना पड़ता। आई एम नॉट अप्रिशिएटिंग माई सेल्फ, आई नो कॉन्फिडेंटली, अल्हम्दुलिल्लाह आई हैव दैट मच कैपेसिटी। तो आप भी उस लेवल पे आइए, अदरवाइज वही चीजें होंगी कि आप टाइप करते रहेंगे, मैं खाली देखता रहूंगा। मैं जवाब तो नहीं दूंगा कि व्हाई डिड वी टेक +200 इंस्टेड ऑफ -200। ये समझा दिया हमने, ये सब समझा दिया, समझाया। We are calculating magnitude of energy. How dare you to ask these type of silly questions? प्लीज जब भी आप क्लास में बैठते हैं थोड़ा सा दिमाग लेके बैठिए साथ में, प्लीज प्लीज। आंसर इज 0.98 किलो कैलोरीज पर ग्राम, गलत है। 3.9 ठीक है, वेरी गुड। आंसर इज 0.934, अब्दुल वासे, यस। सईद कहाँ गलती करे देखो, आंसर इज 0.934 किलो कैलोरीज पर ग्राम, एक्सेलेंट। एंड सेकेंड वन इज 3.93 किलो कैलोरीज पर ml, सईद उर रहमान, दैट इज करेक्ट। सेकेंड आंसर आपका सही है, फर्स्ट आंसर में थोड़ा सा प्रॉब्लम है, दैट इज 0.934। ओके, come on, anybody else? Right, चलिए, come back to next question. Very good, only 2 answers. One answer is 0.934. Sohail, one answer is 9. Which answer, beta? Which answer? Is it per gram or per mole? लिखो यूनिट जैसा हम लिखे वैसे लिखो। मुस्तफा 0.93, ठीक है, नो प्रॉब्लम। किलो कैलोरीज पर ग्राम, यस सोहेल, इट्स करेक्ट, पर ग्राम, यू आर राइट। चलिए, वेरी गुड। मुस्तफा 3.9 नहीं है बेटा, 3.94 है, लेकिन एक्सेप्ट कर सकते हैं बिकॉज 4 ऑप्शंस में आपके पास 3.94 का मतलब यू आर क्लोज टू द आंसर, देयरफॉर नो प्रॉब्लम, गो अहेड। नेक्स्ट क्वेश्चन नंबर 13। 13th question is a gift for all of you today from my side. Tuesday gift, let us enjoy that word. A beautiful question, make a star on the question. Heat of solution of anhydrous copper sulfate. I'm writing those words because they're important. Heat of solution of anhydrous copper sulfate is minus 15.9 kilocalories. ठीक है, and that of heat of solution of copper sulfate 5H2O, ये है hydrated form, is 2.8 kilocalories. Calculate the heat of hydration. Calculate heat of hydration of copper sulfate. ठीक है, थोड़ा ध्यान से सुनिए, ब्यूटीफुल चीज है जो मैं आपको दे सकता हूं। वो क्या है? सपोज फॉर, ये कॉन्सेप्ट हम पढ़ चुके हैं लेकिन फिर से मैं रिपीट कर रहा हूं। सपोज फॉर एग्जांपल, इफ आई एम हैविंग कॉपर सल्फेट, दिस इज नोन एज अनहाइड्रस, मींस विदाउट वाटर। Okay, now if suppose for example you are adding water, okay, how much amount of water? You are not taking care of that, you are adding water. Whenever you add water, in the classes what I said, if you add quantitatively, sir, I am adding 5 moles of water because I know that copper sulfate forms pentahydrate, rule number 1, right? So it will be, if when you add 5 moles of water, it will form copper sulfate dot 5H2O. Job is finished. That is called enthalpy of hydration. the amount of heat energy released when 1 mole of anhydrous copper sulfate is hydrated by required number of moles. Okay, fine. But suppose, for example, law number 2 has added water without having any limit, then copper sulfate is so much genius that it will first of all accept only 5 moles of water. It will accept only 5 moles of water, even though you are adding excess amount of water. Therefore, the method of problem inside the reaction vessel, something takes place like this. It will accept 5 moles of water, right? And who is this fellow? Solid. And then it will convert itself to copper sulfate dot 5H2. And who is this fellow? This is also solid. And what is the name of this fellow? Hydrated copper sulfate. Then, because he added excess amount of water, then he says, okay, I'll go and enjoy the game like this. Copper sulfate dot 5H2O, and this is aqueous, right? Now, this one is known as enthalpy of hydration of copper sulfate. This is called enthalpy of hydration, alpha, right? You may not, I'm not having space here, so I'll write separately. What is alpha? Alpha is enthalpy of hydration of copper sulfate. Acha. Then what is this? ये क्या चीज है? ये है एंथैल्पी ऑफ सॉल्यूशन. जब ये वर्ड एक्वस आ गया सबस्क्रिप्ट में, इट इज कॉल्ड एंथैल्पी ऑफ सॉल्यूशन. दिस इज बीटा. व्हाट इज बीटा? बीटा इज एंथैल्पी ऑफ सॉल्यूशन ऑफ व्हाट? ऑफ अनहाइड्रस कॉपर सल्फेट. ठीक है. अच्छा, ये क्या है? गामा. What is gamma, sir? Gamma is enthalpy of solution of what? Hydrated copper sulfate. Right? ये आपको क्लियरली समझ में आना है कि yes, these are the things. पहले आप ये बोल रहे हैं, लेकिन ये ऐसा नहीं होता. पहले ये ऐसा होता है, फिर ऐसा होता है. चलिए, अब apply Hess law. What Hess law says? When a chemical reaction takes place, either in a single step or number of steps, sum of all the energies must be constant. Matlab beta is equal to alpha plus gamma. Chaliye, beta. What is beta? Enthalpy of solution of anhydrous copper sulfate. Sir, heat of solution of anhydrous copper sulfate. How much? Minus 15.9. Then, sorry, ये कहाँ लिखना था मुझको? एक मिनट. चलिए, what is that? We are writing beta, enthalpy of solution of anhydrous copper sulfate. Okay, I'll substitute here. Minus, what is that? 15.9 is equal to alpha. What is alpha? Enthalpy of hydration of copper sulfate. The question है, sir. The question है. Plus gamma. What is gamma? Enthalpy of solution of hydrated copper sulfate. Enthalpy of solution of hydrated copper sulfate. How much? Plus 2.8. Job is over. 4 marks in your pocket. Alpha is equal to minus 15.9 minus 2.8 is equal to 7 is equal to 8 is equal to 1 minus, and what are the units? Kilo calories. Go ahead. over next. Question number 14. Sure. Now see this reaction again, another new concept. Calculate the heat of neutralization. Very good. Enthalpy of neutralization. Once you read the word enthalpy of neutralization, in your mind, so many sounds are ringing. It is the amount of heat energy released when one equivalent of acid reacts with one equivalent of base to form salt and water. This to be ringing out in your mind. Then you can say, sir, yes, I am on the right track. Calculate the heat of neutralization from the following data. What is the data given to you? 200 ml, okay, 200 ml of 1 molar HCl is mixed with 400 ml of 0.5 molar NaOH. ठीक है? The temperature rise in calorimeter. This whole experiment is done in an instrument known as calorimeter, and then delta T, temperature rise, is found to be how much? 4.4 degrees centigrade, he said, not necessary. Water equivalent of calorimeter is 12 grams, and specific heat is 1 calorie per ml per degree. Nice. For the solution, specific heat of solution. Now, this is thermochemistry plus stoichiometry plus heat chapter in your physics. I think heat has not been yet started to you because heat we usually discussed in the last case in MS. In Narayana Chaitanya, it is reverse. But I don't want all those things. What we want is how to explain to students. Very simple, very simple. Go back to 10th class and try to enjoy it. First of all, try to learn this question. What is the meaning of this? Enthalpy of neutralization. Very simple, sir. I have to calculate the amount of heat energy released when one equivalent of HCl react with one equivalent of NaOH. Come on, allow them to react. How they are doing reaction? HCl is enjoying a gain along with sodium hydroxide. There is a formation of salt and water, sodium chloride plus water. Now, at time t is equal to 0, stoichiometry, number of millimoles. Here I can use moles and I can use equivalents because valency factor is same, right? Millimoles I am saying, take millimoles, okay? No problem. Because if it is moles also, go ahead. What is millimole? Molarity into volume in liter, molarity into volume in liter, 200 into 1. No, sir, I want to enjoy millimoles. Okay, it becomes moles now, 0.2 moles. Next. What about this one? 400 into 0.1. 400 into 0.1. This decimal cancel again 200. What is the meaning of 200? This is also 0.2. What I am discussing here? Moles. Right? 0.2 moles and 0.2 moles. Do you have any limiting reagent? No, sir. Both of them are present in sufficient quantity. Therefore, when the reaction is over, I got 0, 0, and I got 0.2 moles of salt. No problem. Come on. What I have learned, 0.2 moles of HCl is involving along with 0.2 moles of NaOH, so as to form 0.2 moles of salt. Remember, our reference discussion is salt, 0.2 moles of salt. Whatever the energy released during this process, this energy is used to heat this system. Who is that system? Calorimeter is instrument. We have to take care of this plus solution, both. Now go to 10th class. In 10th class, what we have said, sir, Q is equal to ms delta T. Are you able to understand this? Yes. Mass of the body, specific heat of the body, increase in temperature. And remember this M into S. What is M? Mass. What is S? Specific heat. Is also known as water equivalent of कैलोरीमीटर. याद है तो ठीक है, नहीं याद है तो ठीक है. क्या करना, अब समझ जाना कि इसको ऐसा ही बोलते हैं. क्यों बोलते हैं, क्या है इसका मतलब, क्लास में काम नहीं करना चाह रहे हैं. समझ में आई बात? इसको समझने का तरीका क्या है? सर समझ में आ गया, वेरी गुड. नहीं समझ में आ गया, वेरी गुड. स्क्वायर. व्हाई वी हैव टू मेमोराइज दिस. What is M? Mass. What is S? Specific heat. What is M into S? Okay, our organization name. No sir, it is called water equivalent of calorimeter. Delta T he has given. अब चीजें कितने हैं? दो है आपके पास. एक तो हो गया ये. चलिए इसको हम जरा सलीके से लिखेंगे. कैसे लिखेंगे? इसको यहाँ से बोलेंगे जाइए, इसको बोलेंगे यहाँ से आइए. ये है. अब इसका क्या होगा? कुछ नहीं होगा सर. ms डेल्टा टी. m s स्पेसिफिक हीट ऑफ सॉल्यूशन दिया हुआ है. अब रुकी कहां बात आके, m. व्हाट इज मास? ओके, 200 ml plus 400 ml, 600 ml. Sir, he is asking about mass. Okay, density is given in the question. No problem. From our pocket, we'll remove one thing. This called density is taken as 1 gram per ml. Therefore, this mass is now become as 600 grams. Come on, start the story. Total amount of heat energy released in case of 0.2 moles of HCl, making neutralization with 0.2 moles of NaOH to form 0.2 moles of salt is equal to ms delta T of calorimeter plus ms delta T of solution. ठीक है? ms delta T, calorimeter, water equivalent 12, delta T 4.4 plus mass of solution 600 grams, specific heat 1 calorie, no problem, into delta T 4.4. Okay, you got it. Answer. What is that answer? Alpha calories. Done. Now the question is, sir, this is the alpha amount of calories released when 0.2 moles of base is formed, salt is formed. Okay, this means to say heat of neutralization is the amount of heat energy released when 1 mole, 1 equivalent, okay, supermarket problem. 0.2 equivalents or moles, both are same, is equal to alpha calories. No, I want 1 mole, 1 equivalent. How much? Answer is enthalpy of neutralization is equal to alpha into 5. Okay, what is that? Beta. What is beta? Calories per mole enthalpy of neutralization. What is that? Strong acid, strong base. Sir, itna tension kyun le rahe hain? Direct बोल देना answer 13.7 because we know it. Is it known to you? Yes. Enthalpy of utilization of strong acid and strong base is 13.7. Right? ऐसी हिमाकत और होशियारी एग्जाम में नहीं करना. जो नंबर आया वही लिखना. यहाँ नंबर 13.7 नहीं आएगा. Go ahead. Right. Since it's a big number, Saeedur Rahman, make it kilocalories. Your answer is absolutely correct. Right? The way of writing is divide by 1000, it becomes how much? 13.464. Very good. I should put it as kilocalories per mole, right? Okay. Yes. That will stop here. Remaining, we have some more questions to enjoy with new concepts, right? And what is the answer we have tried? Very good, Muhammad Moise. We have tried answer as minus because we know that enthalpy of utilization is the amount of energy released. Magnitude is, of course, positive. Okay, come on. That will stop here. Remaining we'll discuss tomorrow. And this Sunday, we are going to enjoy only thermochemistry 22 questions, whatever it may be, because I think the remaining part will be given by Krishna Mohan sir. We'll go for thermochemistry. Okay, thank you. Assalamu alaikum.